Every day, billions of dollars and millions of lives move vertically through buildings. Yet one question remains surprisingly mysterious. To most passengers, an elevator is simply a moving room, but hidden behind the walls is one of the safest transportation systems ever engineered. At first glance, the idea seems terrifying. A heavy box hanging high above the ground by a few steel cables. If those cables were all that stood between passengers and gravity, elevators would be far more dangerous than they are. In reality, cables are only the beginning of a much larger safety system. Let's imagine the worst possible situation. Every supporting cable suddenly snaps at the same moment. Would the elevator instantly plunge toward the ground, like a scene from a movie? The answer reveals one of the most brilliant hidden mechanisms in modern engineering. To understand elevator safety, we first need to understand how elevators actually move. Most modern elevators do not lift themselves directly. Instead, they operate through a carefully balanced traction system. The first hidden secret is the counterweight. The counterweight offsets most of the elevator's mass before the motor does any work. This means the motor is not lifting the full weight of the cabin. It only manages the difference between the two sides. That dramatically reduces energy consumption while increasing overall control. The next secret lies in friction. The cables are not simply hanging from the machine. They are tightly wrapped around a specially designed wheel. The friction between these surfaces allows precise control over movement. Without enough friction, the elevator could slip. With too much, efficiency would suffer. But perhaps the most important detail is something most passengers never notice. Modern elevators do not depend on a single cable. They rely on multiple independent cables, each capable of carrying far more weight than its normal share. Each cable carries only a fraction of the total load, creating a powerful layer of redundancy. Even if a single cable fails, the remaining cables are fully capable of supporting the elevator. And each cable is far stronger than it appears. A modern elevator cable contains dozens of high-strength steel wires working together as one structure. Together, these cables can support many times the maximum weight they will ever experience. But engineers never rely on cable strength alone. The real protection begins with a device called the safety gear. This mechanism exists for one purpose: to stop a falling elevator. Every elevator travels along rigid steel guide rails. These rails do far more than guide the cabin. They also serve as an emergency braking surface. If necessary, the safety gear can clamp onto the rails with enormous force. Under normal operation, passengers never know these systems exist. The next question is simple. How does the elevator know when something is wrong? The answer lies in another hidden device called the overspeed governor. This mechanical watchdog constantly monitors the elevator's speed. As the cabin accelerates, the governor spins faster and faster. At a critical speed, physics takes over. Centrifugal forces trigger an automatic locking mechanism. That action immediately activates the safety gear connected to the elevator. Long before the cabin could reach dangerous speeds, the elevator is mechanically forced to stop, proving that gravity is never allowed to work alone.